The textbook might have gone another step here. I have no idea. They might have rationalized. There's no need to do this. I might have done this. There's no need to do this. I personally do like it. I think it's prettier than this one. But I wouldn't say one of these is worth more points than the other. However, if you leave it like this, you're going to lose points. The r squareds cancel. If you leave it like this is gross. There's fractions inside of fractions. Don't leave it that way. If you leave it like this, it's not simplified. There's all sorts of things to simplify. So simplify within reason does say you got to go down to here. It's a little weird, those directions. But you got to keep going until you get to the end. And you don't know where that is unless you've seen it. Yeah?
Can you leave your answer
No, because the people with large sticks will jab at you. Remember that story? Just say yes so we can move on. Okay. I prefer you don't leave it as 1 over r squared plus to the 3/2 power, or r squared plus 1 to the negative 3/2 power, or any of those kinds of variations, only because we're not supposed to do that. I don't think I would take a point off, but I'm not going to even write it down up here. What else you got? Jeffrey.
3, 5, 68. The cycloid one. It's x equals r times the parentheses.
Huh?
Parentheses.
Okay, keep talking.
Oh, theta minus sine theta. Y equals r times 1 minus cosine theta.
What was the one? All the places where the cycloid's horizontal or something?
Where the tangent.
Ask
Find
the
the
question.
equation of the tangent to the cycloid at the point where theta equals pi thirds.
Thank you much. Okay, if you let theta equal pi thirds and you put it into this thing, you're going to get x equals r pi thirds minus sine of pi thirds. Square root 3 over 2. You're going to get y equals r 1 minus sine of pi, cosine of pi thirds is half. So it's, I'll simplify it a little bit here. X is pi thirds r minus square root 3 over 2 r. That's kind of yucky. But the other one's not so yucky at all. Y equals half of r. I've now rewritten the equation because you told me theta was pi thirds. Oh wait, this is for later on. I haven't rewritten the equation. This is still the equation. This is something I think I need later. This is the point. Because you said, let's find the equation of the tangent line, right? This problem is awful. I won't give you this problem on the test, okay? If I did, I would say r is 2. I don't like it when they have multiple variables going on. It confuses the heck out of people unnecessarily. But if I gave you the radius was 2, then I would have a point now. It'd be, you don't need to care. It'd be a point, okay? And the equation of the tangent line is y minus y1 equals m times x minus x1. And this is ugly as all heck. I mean, it's just nasty. But you see how I'm almost done. All I need now is slope. I haven't done any calculus yet. All I've done is answer the question of what point happens at pi thirds. Okay? Now I need to find out what slope happens at pi thirds. Here's where calculus takes over. The slope at pi thirds is going to be the derivative of the y value with respect to theta over the derivative of the x value with respect to theta. So I got to take a derivative of y. Now, this is going to confuse people because they see the r floating there and they don't know what to do with the r. So if I did this problem, if I gave this, if I wrote this textbook, I would say, I would just put a 2 here. And people wouldn't freak out so much. What's the derivative of 2x squared? Say it quick.
4.
What's the derivative of 2 tangent x? What's the derivative of 2f of x? 2f prime? Do we agree that 2 just floats? Can I go back to here? Oh, not there. Okay, so if I take a derivative of y with respect to theta, do you agree that the r value just floats? All right? All right. So what's the derivative of 1 minus cosine theta? Very good. I heard it. Someone said it finally. Any questions about how the derivative of 1 minus cosine theta is sine theta? People always ask this question. I know it's really confusing. I know it's an awful question. But however, if you look at what you actually have to do, what's the derivative of 1 minus cosine theta? No one's confused there, right? That's the only calculus here. So then you have to ask yourself, are you really confused about the calculus of this problem? Or is it just kind of a weird problem? And the weirdness is the R. The R screws you up. So when math is difficult, make it easier. Now it's way easier. What's the derivative of 1 minus cosine? Sine. Okay, but you can't do that. You can't just erase something that bothers you. So put it back. How do I deal with the R? Well, what if it was a 2? How do I deal with the 2? And you do it the same way. Shall we take a derivative of x? Sure. What's the derivative of R times theta minus sine theta? R times 1 minus cosine theta. And what do you immediately notice about the things you hate? See you later, things I hate. So far, so good? So, I mean, I know people look at this thing and panic. I get that. I understand panic. I understand panic really well. I'm married. But if I put in sine of pi thirds here, and I do 1 minus cosine of pi thirds, here's a pi thirds triangle. Sine of pi thirds is square root 3 over 2. Cosine of pi thirds is a half. Well, that's disgusting. So let's multiply everything by 2. That's prettier.
I didn't do it. No.
There's your slope.
Did you
Final answer for this problem. Y minus R over 2 equals square root 3 times x minus pi thirds of R plus square root 3 over 2R. It's kind of yucky, but really it's the R stuff that makes it yucky. If you just change the R, the problem would be so much nicer. There you go. Here's that one. What else do you want to talk about? Nate.
3537.
3537.
Suppose that k of x equals f of g of x.
You say tangent of x?
K of x.
K of x. I hear you now. K of x equals f of g of x.
And g of x, and g of 3.
I'll get all the numbers and stuff later. What's the question?
Find k prime of 3.
Okay. I'm going to find k prime of 3 soon. But first I'm going to find k prime of x. You ready for this? How do you take a derivative of f of g of something else? That's confusing as all heck. Let's just pretend that wasn't there for a second. The derivative of f is f prime. So the derivative of f of stuff is f prime of that stuff. You just ignore the thing that's on the inside. But now that I've done that, I have to account for the thing on the inside. This is called chain rule. G prime x. Do you see how the derivative of f of g of x is f prime g of x times g prime x? So the question says, what's k prime of 3? So that's going to be f prime of g of 3 times g prime of 3. And now, Nate, I'm going to ask you to look some stuff up for me. What does g of 3 equal?
6.
Okay, I'll come back to you in a second. Now I'm going to ask you, Nate, what's f prime of 6?
7.
What's g prime of 3?
4.
Okay. So they gave you a bunch of numbers. You don't have to use all the numbers. We got to use some of them. The big important thing is to understand what the heck this notation is saying. And keep in mind, this notation, there's another notation like this, but they won't do f of g. Do you know what notation I'm talking about? It's the other style of notation for this that sometimes they write. Fog. Happens at the coast quite a bit. In Newport, they write this. So if the question was find f of g prime of 3, it'd still be 28. But if you ever see a fog notation, immediately rewrite it as f of g of x so you can actually do it. It'd be confusing otherwise. Here's this one. What else do you want to talk about? Junior. She's a junior. 99? I knew that wasn't right. 49?
Find the limit of final points on the graph of the function x by 2 times sine square x, where the tangent line is horizontal.
Are you okay with the derivative part?
Yeah.
Okay. Check the derivative, and we want to find horizontal, so we set it equal to 0. So if you factor out the fact that these both have a 2, and factor out the fact that they both have a cosine, you're left with a 1 plus sine. The only way two things multiply together to be 0 is if either the first thing is 0 or the second thing is 0. So I'm looking for values where cosine of the value is 0 or sine of the value is -1. Now I'm drawing pictures. I like these problems. They pull back everything that you've had to do this year. I mean, this next test, people asked me earlier this year, do we have a final in this class? No, but yes, but no. It's not a final, but yes, it is, because this covers kind of everything we've done, a little bit. You're doing a lot of trig stuff today. Here's a triangle where the cosine of the triangle is 0. Here's another triangle where the cosine of the triangle is 0. And there's an infinite number of answers based on each triangle. Here's a triangle where the sine of the triangle is -1. I don't need this triangle. I already have that triangle. So I think I have all my answers. But that's not the question. The question didn't say find all the x values. It said find all the points. Yeah? So a point means I need an x and a y. So I have all the x's. X could equal pi halves, 5 pi halves, oops, 3 pi halves, 5 pi halves, etc. There's a lot of x's. But I have to figure out what is y. Y is f of pi halves. The original function was 2, I lost it.
2 sine x plus sine square x.
There we go. Like so. So I'm going to find what is the y value for pi halves. That's going to be 2 times the sine of the pi halves triangle. Look at the pi halves triangle. The sine of that's 1. Plus, now I'm going to take the sine of the pi halves triangle, 1, and square it. So I'm getting 2 plus 1, which is 3. So one of my points, it said find all the points, but one of the points is officially pi halves, comma, 3. Now I got to figure out what happens at 3 pi halves. So the y value, which is found by doing f of 3 pi halves, is going to be 2 sine of 3 pi halves plus sine of 3 pi halves squared. So that's 2 times -1 plus -1 squared. That's -2 plus 1, that's -1. So at 3 pi halves, you get -1. Now I did all that a lot faster than last time, but it's the same, it's just a different triangle, and it's stuff that I've taught you before, so I think you can do it. If you did 5 pi halves, and did the whole thing, you're going to get 3. If you do 7 pi halves and did the whole thing, you're going to get -1. So what this thing is doing is it's some kind of periodic function. F of x is some kind of periodic function. Think about sine. This thing hits 1 a whole lot of times. It hits 1 lots. There's this one 1, this one 1, this one 1. It hits -1 in a whole bunch of spots. That one -1, that one -1, that one -1. These periodic functions have a way of having lots of different x values that all have the same y value. Which is why we're going to report lots of different x values, all with the same y value. And we're going to have lots of other x values that happen to have a different x value. And that's going to be all the points where the slope is 0. Lots of x values, they all have the same y value. Follow.
So on the test, would you restrict the point?
On this problem, I may not do that. Might. You wish I would. But this time it's not quite as horrible as the other ones. Still horrible, not as bad as the other ones.
Well,
What else you got?